So I have a question. So you said the telomeres changed within 48 hours.
Yeah.
Is there like a record for how fast genes can change?
Oh, I mean, how fast genes can change can be almost instantaneous, right? If there's some sort of stimulus that is happening that your body is reacting to, it can be pretty fast for a gene to change. But for telomeres changing, I don't want to say that that's the fastest, but it is the fastest that I have heard. Because the cool thing about telomeres is that they are protecting the ends of our DNA, but if your telomeres get too long, then it sort of interferes with how your cells should naturally be degrading as you age, and you can sometimes have things like cancer pop up, right? Because the cells that should be sort of losing their DNA aren't. So you don't want your telomeres to be way too long because then you can get cancer, but you don't want them to be too short because then your DNA can be damaged. So there's sort of like a happy medium as we all age that we should be sort of sticking in.
Do you have a question?
I do have a question. And maybe you said this during a part where I zoned out because I felt dumb and it was easier to not hear. But why does it need to be twins? Why couldn't you just test someone before they were in space and after?
Because it's cooler if it's twins.
I
So they did do that too. They tested people before and after they were in space. I think it's because it was cool. I'm not affiliated with NASA. I should make that very clear. I'm just a huge NASA fangirl. But it is cool to have a control down on the ground that is genetically identical, but there were a lot of things that were different in their lives over the course of that year, right? They were eating very different food, they were doing very different things every day. So it's not a perfect control, but when do you get to send one twin to space and leave one down on Earth? Like, it is a really cool way to test.
Do you think they tried to get Mark Kelly to just eat astronaut ice cream all year? Yeah.
I wish. I have to, so I mean, he was also an astronaut, so I'm sure that he had his fair share of that food in the past and was probably done with it. The one cool comparison that I did love that they made between the two twins was I'm gonna get it wrong, it's a psychology test, it's the balloon something response test, where you give people a computerized balloon and you have them try and blow it up with a key, and not so that it pops, but right before it pops, and then you get money based on how many times you get it to blow up, sort of thing. And it's a risk aversion test. And they just noted that in the pre, during, and post-flight, Scott Kelly always scored higher. He was willing to take way more risks than his twin at all other times. And it clearly had nothing to do with him going to space. They were just like, he likes taking risks more, and now we know that.
But isn't using twins like a standard in doing genetic studies?
It is, yes. So using twins is definitely a standard in genetic studies because sort of it goes back a little bit to the question of nature versus nurture, right? When we were first trying to figure out like how is everything determined by your genes, is it determined by your environment? Taking identical twins is a nice way to look at two people and say, okay, you have the same identical DNA, we're looking at a trait. Is it more common if you have the same DNA, or is it completely separate? So twin studies are a huge deal in genetics. We just typically don't only do it with one set of twins. But how many twin astronauts do we have, right? Like typically you're doing this with hundreds or thousands of twins, but we only have one set of twin astronauts at the moment.
Questions from the audience? Raise your hand. I'll repeat the question.
Everything that changed with the astronaut that went to space, did it go back to baseline eventually? Do you not know?
Yeah.
So everything about the astronaut that went to space,
Did it go back to baseline? Like, did he return to normal?
did everything return to normal after he got back? It's just for the recording.
Yeah. So yes and no. So a lot of things did. So a lot of the gene expression changes that happened when he went up to space, I think it was 93% of them went back down to baseline pretty soon after, but 7% stayed changed, which is sort of what set off all of those news articles, because they were like 7% of his DNA changed, and it was like, no, just 7% of his gene expression. So a lot of things did. Things like the telomeres came back down to baseline. They actually, one of the things that persisted for a really long time was his cognitive effects. So his cognitive sort of like reasoning and all the testing that they did stayed pretty much the same throughout his space flight. But it then dipped when he came back down to space came back down from space and stayed dipped for about 6 months afterwards. And so they weren't sure why this happened. One of the things that they proposed was that after you come back from space, you have to participate in a lot of both research studies and media appearances. And they were like, maybe that was really stressful to him.
So just in layman's terms, he got dumber?
Yes. But that's important to know, right? If we're going to land on Mars, if when you land, you are not as cognitively sharp as you were when you were in space, then we need to be automating some of the stuff that happens when you land. Like, we need to know that kind of stuff. So yeah, he got
That's
dumber.
gotta suck to go from being like one of the smartest people on Earth and then you can't work the coffee maker when you
Yeah.
get to Mars.
Yeah.
If there's anyone there before, they're like, wow, they're sending us the dumb ones, aren't
Yeah.
they? What's the coolest not like bacteria that they found up there? Is there anything that people found and are like, whoa, this is here?
I don't know that they found anything yet that they're super surprised by. So this is all still, I mean, that's what's kind of cool is that this is all still really new that we're doing sequencing in space. I mean, we just started doing this in 2016. We didn't actually start doing the swabbing of the sidewalls until 2008, late 17 or early 18, I believe, because we had to do so many technical things to make sure that it would work. So currently, they're still just finding things that they expect to be up there, which is good. But the more that we do this, I mean, I think one of the cool things is that it's a closed environment up in space. So there are resupply missions that go up and down, but you could have sort of this nice little evolution experiment because they've been tracking through Petri dishes all of the different things that have been growing up there for years now. But that's limited to what is going to grow on a Petri dish and then survive to go back down to Earth. So if we can be doing this sequencing in real time, we can watch how these bacteria are evolving in space.
Okay, let's say we have time for 2 more questions. Anyone from the audience? You, sir, in the blue.
Did they confirm like what the cause, like 100% what the cause was that made his gene expression change? Was it the space radiation?
Did
Or
they
what is
confirm?
that?
Right.
Goku, the high linear space radiation.
Did they confirm what caused the DNA or the gene expression change?
So they have some theory, or they have some hypotheses about what it might be. So microgravity in response to that is probably one of them. You're also, everything can change your gene expression, including sleep deprivation, right? So you're sleeping upright in a sleeping bag, you're in close quarters with other people, like you're eating prepackaged food. So a lot of these things they hypothesized could be causing these gene expression changes, but they did also look at changes to the DNA that could have been caused by things like the space radiation. And they did find that he had some increases in certain types of breaks and relocations of his chromosomes that were higher after he spent that time in space that they do think were likely caused by the space radiation. So it's something where they can now track, okay, what's the rate, how fast does that accumulate and stuff like that. So they have hypotheses, but no definitive answers yet.
All right,
Yeah, are they sort of looking into how, like, are they just looking into genes in space, or are they sort of looking into how the changes could affect, our, like, gene therapy here on Earth?
That is a great question. So we're doing, I'm not a part of this anymore, right? NASA and like other scientists are doing a lot of cool stuff with that. So some of the stuff that's up there is really just looking at how are humans going to be responding to long duration space missions. But there are also experiments up there for looking at things like, okay, well, what if we want to grow, I used to work in cardiovascular biology, so they're growing heart cells on the space station, which is super cool. They beat all by themselves. They're the coolest things in the world. But they aren't confined by gravity up in space, right? So when we grow them on a dish in the lab, they grow flat, which is not how they happen in our body, right? Our bodies are 3D. And so you can grow them in 3D up in space and see how that changes them and how that might be able to be brought down to Earth as some sort of therapeutic in the future. So everything, the cool thing about NASA is that everything we learn up there helps us back down on here. Like I think memory foam is like the one that everyone goes to, that was somehow developed in NASA, and now we all have memory foam mattresses. So all of that stuff eventually does come back down and help us with questions we have down here on Earth.
okay, Russell.
All
has
right,
the
last question. This is for everybody. What's your favorite gene?
Let's start with. You're the one who has knowledge.
I have a favorite gene. My favorite gene is myosin. Myosin is one of the motors that causes your heart to beat. So it's like a little protein and it grabs onto actin and it causes it to beat and the little sarcomere, and I'm describing it terribly, but it's cute and it's myosin.
I've got a friend named Gene. He helped me out on a tight spot. He helped me make this really bad joke. That's what he did.
This feels like a quiz.
Yeah,
And I won't take it. I'm going to enroll in this class.
The one that makes your toenails?
Gross.
Yeah.
Oh
What do you mean your toenail? What kind of answer is that? Okay, well, I was gonna do mine because my middle name's Eugene. I was like, haha, I'm a narcissist, Eugene. But
took it
lost
from
that one, and it didn't land well, so fuck me. My favorite gene, the one that tells me whether or not Godzilla is gonna be really relevant in my life after this show, because I've gotten to talk about him so much, and you've all been so patient with me. I like Godzilla so much. You don't know. Hey, do you actually want to give an answer? It's okay if you don't.
I don't.
Okay.
I'm gonna say something that doesn't make sense, and you're all gonna laugh at me. I know I look smart, but I am not. I promise you I'm not.
All right, everybody, thank you so much. That has been our show. You're all amazing. Thank you so much for coming out to support live LA-based comedy, live LA-based science. We have some of the best scientists and best comedians in the world. Please go have some fun in 2-Bit Circus. Follow us on Facebook, on Twitter. Follow Alex, follow Paige on Facebook and Twitter. Whoa. Whoa, whoa, whoa. So much science. We're unlearning everything. Too far, but it's good. There, wait, there. That's us. Follow us. We love you guys, and we'll have pictures online. Thanks. Have a great night.